All right, on 21 and 22, we're going to use a process called long division, which you probably remember from elementary school. I'm sure you do. So here, what we're going to do is we're going to start by dividing. We're going to do a nice, easy linear one. This one actually could be used with synthetic division. And then we'll do a tougher one that could not be used with synthetic division because of the fact there's a 2 in front of the R here. In long division, first thing we're going to do is we're going to set it up with your x minus 2 on the outside of your division. And then inside the divisor here, we have the x cubed plus 2x squared minus 6x minus 9. Now this one had each of the different powers of x, so we didn't need to leave a placeholder. But if you were missing one of the powers of x, counting backwards from your highest power, then you would need to put a placeholder in there of a 0 value. But we didn't have that on this one. So now, when you're doing long division, the goal is always to try to make the first term here look like the first term there. Now, since there's 2 terms here, we can't take 2 terms and divide them into 1. So we're going to look at the first 2 terms here in this problem. And we're going to try to make this x, turn into an x cubed. So what would you multiply x by to make it into an x cubed? You would multiply by an x squared. And since it's 1x cubed, we just need to multiply by a 1x squared. So now what you're going to do is this is going to get multiplied by both of these terms. You're going to distribute this to both terms. Okay? So x squared times x is x cubed. X squared times negative 2x is negative 2x squared. Okay? And then we draw the line. Now, the next step in long division, you need to subtract. Okay? And this is the tricky part, because we're subtracting both of these terms. So there's subtraction here and there's subtraction here. So both of these get subtracted. So an x cubed minus an x cubed, those are going to cancel. But now this is the term that people mess up the most. So we got to be careful. You've got a 2x squared minus a 2x squared. Initially it looked like it's going to cancel, but it's not, because this minus a negative turns it into a positive, which actually gets you 4x squared. Okay. Then the next step is to bring the next term down. So that's going to be a minus 6x carried down here. Now we repeat the process. We need to make the x turn into a 4x squared. So obviously you need to multiply by a 4x. So 4x times x gets you 4x squared. Those match up. That's what we wanted. And 4x times negative 2 gets you negative 8x. All right. So now we subtract. So there's minus here and minus here. These terms cancel. Negative 6 minus a negative 8. This turns into a plus. So this gets you positive 2x. Then we bring down the minus 9. Okay. Then we need to know, what do we need to multiply x by to make it into a 2x? Obviously that would be a plus 2. So 2 times x is 2x. 2 times negative 2 is negative 4. Draw your line. We're subtracting. We're subtracting. That cancels. Negative 9 minus a negative 4, which is actually a plus 4, gets you negative 5. And this here, just like in synthetic division, will be your remainder. Okay? So your final answer here is x squared plus 4x plus 2, and then since it's minus 5 over x minus 2. And this here is your final solution, or your final polynomial. It's not really a solution. It's the answer that you get after you divide out the x minus 2 from that polynomial. Okay, so let's try one more. Let's try number 2. Number 2, this is an example which you would not be able to use synthetic division because you have a 2r here. Actually, you could use synthetic division, but it would be very nasty because the 0 here is a fraction, and that you're going to have fractions through your whole synthetic division. So on this one, let's set this up. We have a 2r plus 1, and then inside your divisor here, we have 4r cubed plus 7. Ooh, here's a problem. We are missing a r squared. So we need a 0r squared in there. So this is actually plus a 0 r squared plus a 7r minus 4. And remember, you need a placeholder for each of the different powers, including if you were missing a constant, you would need to fill this in with a constant as well. Okay? So now let's start the process. We need to make a 2r into a 4r cubed. Again, we're going to use both terms because we have two terms here, so we need to use both terms here. So looks like we could multiply by a 2r squared. A 2r squared should multiply together to get you a 4r cubed. And then 2r squared times 1 just gets you a 2r squared. Then we're going to go ahead and subtract these. And you'll see that the 4r cubes cancel, and you have 0 minus 2r squared, which gets you a negative 2r squared. And I would spend some time making sure that this term here is right, because again, that's the term that gets messed up the most. So then the next step is we bring down the 7r. So we bring down the 7r. Now we need to make the 2r turn into a negative 2r squared. So in that, we're going to multiply by a negative 2r. So, we're not going to multiply by a 2. We don't need the 2 there. We're just going to multiply by the r. So that's actually a negative r. So if we multiply that through, we get 2r times the negative r, which is negative 2r squared. Then we multiply the 1 by the negative r. And we're ready to subtract. So we subtract, these cancel. We're going to also subtract these. So 7r minus a negative r gets you a positive 8r. And then we have one more term to bring down, so that's a negative 4. And so now we need to make the 2r turn into an 8r by multiplying by, in this case, a positive 4. So 4 times 2r is 8r. And then 4 times 1 is 4. Positive 4. We subtract. These terms cancel. These also need to get subtracted. So you get negative 4 minus a 4, which is negative 8, which again is your remainder. And now we can just tack our remainder onto our answer. So that's minus 8 over 2r plus 1. And that there will be your final polynomial.